Hey guys, all right, finishing off lesson 8 here before we went kind of like on the classic rules of multiplying exponents, and the theme of it was always when in doubt, write it out. Or if you know the rules, which I was kind of giving and showing why that is the rules, that always works as well. Both things work. This class or this lecture, I'm going to just use the rules a little more. I'm not going to when in doubt, write it out, but if you feel like you're being inconsistent with rules, these adding of exponents and multiplying of exponents and stuff like that, just write it all out. It takes a long time, but it gets you the right answer. So one more caveat. I've seen negative exponents, maybe not prior, but like you will see negative exponents in like the homework and such. And it's good to know that a negative exponent can always be written as a positive exponent. Maybe I'll do this as a side rule as well. If I have 1 over, let's say, x to the negative a, like x to the negative a in the denominator, right? The rule still applies where I change this into an a in the denominator, right? Imagine if I didn't have this, right? That makes it maybe a little easier to see. That's the same exact rule that I just wrote down right here, right? But it's in the denominator, so I can do that. A final step we can do, this is what I was always taught when I was in these lower division classes of like when you're dividing by a fraction, don't ask why, just flip it around and multiply. So this is the same as 1 times x to the a over 1, or just x to the a here. That's like the mathematical algebra reason for this. Um, all you really need to know is 1 over x to the negative a flips to the numerator to just be an x to the a now. This is the reason why it stems from this rule, but this is the rule to have just memorized. When you see a negative exponent in the denominator, you can flip it to a positive exponent in a numerator like this. The 1, you just kind of imagine it being there. Okay, where are we at here? Negative exponents, which is what we were just talking about. In general, good manners in math tells us to simplify to only have positive exponents. Because negative exponents are a little, I don't know, scary. Switching to positive exponents is always a clearer answer here. So when I see 5 times x to the negative 3, I see this is equal to, well, what is x to the negative 3? That is moving it to the denominator. That's the rule that I have here. Whenever I have x to a negative power, I can move it to a denominator. Flip it as a reciprocal. So this becomes 5 times, right? There's a times here, 1 over x cubed. That's the same thing as 5 over x cubed. Note, it's not. I know a couple of you might have been like, wait, isn't it just 1 over 5x cubed? Why isn't it that? Isn't it like a negative 3 power, so everything just goes in the denominator? That's not the case because this 5 is not connected to that negative 3 power. It is 5 times x to the negative 3. If this was all in parentheses, like this, 5 times x to the negative 3rd power, like this is saying, in math land, this is saying this entire thing in the parentheses is the base. So then you do what you would think you would want to do, and this would be your answer. You move that entire base down and you put it to a positive power. We don't have that case here. We just have 5 on its own land here. So this is the answer. Okay, let's do this next one. This is a little silly of one. I have negative exponents in the numerator and the denominator. Well, this 2 is kind of just doing its own thing. When I have a negative exponent in on the numerator, like this becomes positive in the denominator. So I'm going to have an x to the 1. This is a negative in the denominator, so I change it to a positive in the numerator, x to the 3 power. Remember, we have these two rules here. Rule 1 is when I have a positive, or when I have a negative exponent, I can flip it to the denominator. With a negative exponent in the denominator already, I flip it to the numerator. So that's what we do here. And now we can simplify further because this is a lot easier. I have 2 times x times x times x over x. One of these cancels. I'm left with 2x squared. That's my answer like that. Okay, lastly, it's best again to simplify to only have positive exponents. So I see a negative exponents inside this squared thing, right? That b to the negative 2 power. It's not that everything is to the negative 2 power, it's just this b. So what I'm going to do, I'm going to leave this squared. We'll deal with the squared in a second, right? I'm going to change this to 6a squared over b squared. See what I did there? I changed that negative exponent to a positive exponent in the denominator. And now we're kind of off to the races of what does it mean to square something? Well, it means I write it twice times 6a squared over b squared, right? You might know what it means to square each of these individual things, right? But I like to write it out. I see 6 times 6 becomes 36. A squared times a squared, adding those exponents now, or writing it out, a times a times a times a. This is a to the fourth. And similarly, b squared times b squared in the denominator, b to the fourth as well. If you can already see this is by just kind of squaring everything on the inside, you can do that too. You can utilize this rule here, but I like to write it out sometimes. Okay, so let's remind ourselves. The rules for exponents, copy, are as follows. And now let's just do some extra practice, just kind of putting it all together. So I'm going to work with these. Let's put these more to the right here. So we just kind of start. Okay, I see 7x squared times to the 2 power. Well, what is that? When in doubt, write it out. 7x squared times 7x squared. Or 7 times 7 is 49. Notice how when I have these numbers, I'm not doing 7 squared or something. I know what 7 times 7 is. It's just 49. So I'm going to say 49 x squared times x squared by adding these two together is x to the fourth. Another thing that's a little that I'm just kind of doing in my head, right? I see these things of the same base. I want to combine these together. I see these numbers. I want to combine these together, right? So I kind of like put the numbers together in my head. I put the exponents together in my head, and I write it in a clean number times variable. That's usually like the style of what we do here. All right. Oh man, 1000 x to the fifth to the 0 power. This is going to be a huge number. Oh wait, no, it's to the 0 power. It's 1. Right. You should be so happy whenever you see these problems, right? Anything to the 0 power, 1, right? Okay, 2y to the negative 2 to the 3 power. What do I like to do? I like to move this to a positive power first. So what rule did I use? I used this rule. 1 over, or excuse me, I used this rule, sorry. X to the negative a is 1 over x to the a. So y to the negative 2 is 1 over y to the 2 cubed. And I'm going to not write this one out just to kind of show how it would go when you don't write it out. I see this is a 2 cubed and a y squared cubed. 2 cubed is 2 times 2 times 2, or 8. Y squared cubed is using this rule, y squared cubed. 2 times 3 becomes y to the 6th. If you didn't see that, it's okay to write it out. Y squared, 2 times y squared. Because when in doubt, you can write this out like so. And I see 2 times 2 times 2 is 8. Y squared times y squared times y squared. That's y to the 6th, like so. Let's maybe make that a little cleaner. Okay, where are we at next? Let's do 3a to the 7th b squared times 2a cubed b to the 4th. Okay. I see I can square this thing on the left first. When in doubt, I can write it out. 3a to the 7th b, what, this was just b, right? Yeah, b times 3a to the seventh b. That is from writing it out twice. Maybe I can change this to green so you can kind of see that splitting it out. And then times 2a to the cubed b4. Now I want to, all in one step, combine the numbers, the a's, and the b's. So how am I going to do that? I see in three. This remember, I kind of just say 3a to the seventh b, right? As if like that's just all one thing. Remember, whenever we change letters or numbers like this is 3 times a, times b, times 3, times a to the 7, times b, times 2, times a to the cubed, times b to the fourth. And because multiplying is the same no matter which way you do it, I can rearrange these around and just multiply these numbers together. 3 times 3 is 9, times 2, 18. A to the seventh times a to the seventh. Well, I'm multiplying with the same base. So I add those exponents. That becomes 14. A cubed, that's going to be 17. A to the 17 here. Lastly, b times b. So this b to the 1, that's b to the 1, that's b to the fourth. That is adding all those together, b to the sixth. B to the sixth, like that. And not that bad. If you're using these rules, it's not that bad to use. Okay, what else do we have here? Let's do this one now. I see this is xy squared z cubed over 3z squared squared. You might be like, okay, when in doubt, write it out. I see I can simplify this first. I see I have a z cubed and a z squared. How do I simplify that? Well, let's write out this squared because I'm not going to deal with that yet. I'm not going to deal with these, right? I'm just wanting to simplify this part. Z cubed over z squared. What rule are we using? Well, when you're dividing by bases of with this dividing exponents of the same base, you subtract this. So this minus this minus this. Z minus 2 or 3 minus 2, z to the 1 power, like that. Okay? And now, when in doubt, write it out. Y squared z over 3 times xy squared z over 3. Notice I'm not writing everything out. I feel comfortable with adding exponents, but when I have like stuff to the 2 power, it's like, I don't really know how that ends up working. So I'm just going to write it out. I have x times x, which is x squared. I have y squared times y squared, which is y to the fourth. I have z times z, which is z squared. And I have 3 times 3, which is 9. That's my final answer. Okay, so this is the last one. This is going to be your star problem. Your star problem is to do this, but also write down which rule you use in each step. So I see some negative exponents. You're probably going to use one of these two rules, right? I see a 3 power like this. You might, when in doubt, write it out. If you say, when in doubt, write it out. That is also like a rule that we're using here. You can expand these exponents to like do something that's more simple for you to recognize. But this is the star problem for this set of videos for this lesson. Thank you guys for watching. I hope it wasn't too bad. These are more just extra practice of being like kind of rapid firing them. This prior video was more like finding and showing why the rules work. Um, Please email me if you have any questions, and thank you for watching. Have a wonderful day.